GameSci.com. GameSci.com. Welcome to GameSci.com. I am Professor Chris Ferguson. GameSci is where we learn game programming and computer science at the same time. This is CS1, Intro to Computer Programming. This course is a series of 10 lessons, and this is lesson number 2, Variables and Data Types. Since we will be building a simple game piece by piece, it's best if you watch the videos in sequence. While we build a simple game, you will also learn object-oriented programming and the important concepts of computer science. What is a variable? According to the website dictionary.com, variable, likely to change or vary. Subject to variation, changeable. I've always thought of a variable as a location in computer memory where I can store a value. Consider a 2D Mario-style video game, with the main character moving about the screen. There's no more important values than the location on the screen of your Mario. X position equals 20, Y position equals 50. 2D means 2 dimensions. An x-axis and a y-axis. And a y position, x position are the variables that will determine where your character will be drawn on a 2D screen. As these values change or vary, the Mario will move about the screen. Whether you think of a variable as something that changes or a value stored in memory, there are 3 critical aspects you need to understand. A variable has a name or identifier. In this case, X position and Y position are the names. A variable has a value. In this case, 20 for X position, 50 for Y position. A variable has a type. In this case, both are integers, or int, a number without a decimal point. Variables must have a good name. Here's a little code. Without looking below, try to figure out what it does. S equals 842. H equals 99. T equals 03:56. The answer is you can't. You can't know what this code does because short cryptic variable names like S, H, and T are terrible. My number 1 advice to any beginning programmer is to give your variables names that clearly describe what is being stored in those variables. Here is the same code with much better variable naming. Score equals 842. Health equals 99. Time equals 356. Now the code is clear. We're keeping track of the player's score, health points, and time spent on the current task. Not only that, a good variable names means we understand what should be assigned to those variables. A score should be a positive number. If you see a value like Fred in the score variable, you know instantly that it's wrong. In a typical game, health is 100 for full health and 0 when you're dead. If you see a value like minus 329,456 in the health variable, it's a giant red flag that something is wrong. The time variable now becomes clear. It means 3 minutes and 56 seconds is the elapsed time spent on the current task. A complicated game may have thousands of variables. If you think you can use short, cryptic variable names like S, H, and T, you won't make it to the second level of your own game. Clear names that describe what is stored in the variable and provide an understanding of values that should be in those variables is the way to go. Bonus points if those variable names match the actual information scored or displayed on your game. Here we see score is 842. If that's shown as the score on the screen, then name the variable score. If the label on the screen informs the user their health value is 99, then name the variable health. Right? The time variable should match what's shown on the screen. You are testing the game and some strange value shows up in the upper left-hand corner with the health value of minus 957. Now you can search your code for any place for the variable health was modified. Or you can struggle to remember that H was the variable and to search for H. Short variable names are a fool's choice. They save you a fraction of a second of typing, but lead to hours of misery when you try to read and understand your own code. Frankly, it's easier to use literal variable names. You need a variable to track the speed your marker character is moving. Should you name it S, SP, or name it Speed? Doesn't that make a lot more sense than trying to figure out the shorter variable name? Variables have a value. I've always thought of a variable as a location in computer memory where I can store a value. It is important to understand that because the source of many bugs in computer programming is bad values stored in variables, being able to recognize bad versus good values in a variable is key to being a good programmer. Good variable names can greatly assist with this recognition. With the variable health, the range may be defined as 0 as dead to 100 full health, and any value outside that range is instantly viewed as bad. But I tire of the Mario game examples. Let's move on to card games, played with a standard deck of 52 cards. Games like blackjack, poker, or go fish. Common to all these games is a card is dealt from the deck to be placed into a player's hand. Deal card equals ace spades. Notice the fine variable name that accurately describes the card being dealt. But focus on the left side of the assignment, the equal sign. This is the value being stored in the variables. The ace of spades is a card taken from the deck. Clearly, there are only 52 values that could be assigned to the variables. Now, here's some examples. Deal card equals 4 diamonds, or deal card equals queen of hearts, or deal card equals 6 of clubs. Being a good game programmer takes an ability to think in a more abstract manner. Values like ace spades, 4 diamonds, queen hearts are going to take up a lot of memory we do not need. What if we used a single letter to represent the rank and suit of each card? The characters 2 through 9 obviously replace 2 through 9 spelled out. Then use an A for ace, a K for king, a Q for queen, a J for jack, a D for 10. The suit is easy to represent with one letter. H for hearts, S for spades, C for clubs, D for diamonds. This means that 2 simple characters could represent all 52 cards. As in deal card equals AS, or ace of spades. Deal card equals 4D, 4 diamonds. Deal card equals QH, queen of hearts. Deal card equals 6C, 6 of clubs. The ability to think abstractly, to recognize the value TC as the 10 of clubs and 3H as the 3 of hearts is important. Not all games are written for a PC with 8 gigabytes of memory. What about smartphones or iPods? Games for these devices have to be small and fast. Let's go even more abstract. Could we use a number to represent a playing card? Sure we could. There are 52 cards. Simply assign 52 unique numbers to represent each of those cards. Let's use 0 through 12 to represent the ace of clubs through the king of clubs. So in this example, 1 is the 2 of clubs. Use 13 through 25 to represent the ace of diamonds through the king of diamonds. So in this case, 15 could be the 3 of diamonds. Use 26 to 38 to represent the ace of hearts through the king of hearts. So 37 would be the queen of hearts. Use 39 to 51 to represent the ace of spades through the king of spades. So in this case, 49 would be the jack of spades. There's no magic here. I'm simply taking a set of 52 numbers, 0 through 51, and mapping it to a set of 52 cards. 0 will be my ace of clubs, 51 will be my king of spades, and every card in between will get its own unique number. My point is, you need to understand variables have values assigned to them, and sometimes those values represent what you're storing. So I can say deal card equals 39, and this would be the ace of spades. Or I could say deal card equals 16, which represents the 4 of diamonds. Or deal card equals 37, which is the queen of hearts. Or deal card equals 5, which is the 6 of clubs. Sometimes it's simply more convenient to use numbers rather than text to represent an item. Numbers are easier and faster to manipulate within a computer program. They also generally take less memory. The point is, variables have values. That value could be a literal Queen of Hearts, or the more abstract QH, or the even more abstract number 37. As long as the entire program agrees that 37 represents the Queen of Hearts, you can use a number to represent a playing card. Variables have a type. The third element to consider when dealing with a variable is the type. What kind of data are we storing in the variable? The three most common types are an int, a whole number or integer, no decimal point. Examples are 42, 17, 0, -6, etc. A double, a floating point number with a decimal point. Examples are 3.14159, 0.00748, -1.3, etc. Or a string, multiple characters, text, letters. Examples could be Fred, or Ace of Hearts, or 123 Main Street. Right? There's two addition variable types that most languages support. One's a char, a single letter or character. Examples would be A, uppercase A, lowercase d. 4, now that would be the character 4, not the number 4. There's a difference. Or the ampersand character. There's also a Boolean type, which can only hold values true or false. Only two examples are true and false. Some computer languages like Java, C, and C++ are what's called strongly typed languages. In those languages, you have to declare the variables before you use it. Other computer languages are what's called loosely typed, and in those languages like JavaScript and PHP, you do not have to declare the variable up front. In JavaScript and PHP, the variable automatically assumes the type of whatever you assign to the variable. If you assign an int to a variable, it's automatically an integer. If you assign a string to a variable, it will be a string. So, let's work through an example of creating a variable from scratch. We're programming a first-person shooter, and of course, the primary thing we're going to have is a weapon. I want to show the weapon right there at the bottom of the screen, and we need to know what to do when the fire button is pressed. There are three things to consider when creating a variable: name, value, and type. First, the name. Call it weapon, because that's what it is. Don't use a silly shortcut like W. The value and type of the variable has to be decided together. If you decide to use values like pistol, shotgun, rifle, or fist, then the type has to be string. In a strongly typed language like Java or C++, we first declare the variable to be type string before we actually assign a string to it. So we say string space weapon. Java requires you to declare the type. After that, you can say weapon equals shotgun and assign it multiple letters or a string of characters. In a loosely typed language like JavaScript or PHP, simply assigning it shotgun would make it a string. Weapon equals shotgun. Just the assignment is needed in a loosely typed language. Like with most computer programming, there are advantages and disadvantages between strongly and loosely typed language. However, for beginners, there is an important advantage. Once you have declared the weapon as a string, then when you do something like weapon equals 1, this will clearly and obviously let you know that it is a mistake and you should be assigned a string. A loosely typed language does not issue an error when you assign the wrong value, because changing the type is allowed. This can lead to significant errors when one part of the program thinks weapon is an int and another thinks it's a string. This is a key computer science concept. When creating a variable, we must decide on a name, a value, and a string. Another key computer science concept: some languages like Java and C++ require you to declare the variable before you use it. Other languages like JavaScript and PHP do not require declaration. Whatever you assign to it is assumed to be the type. Declaring variables. There are two general formats for declaring variables: type space name semicolon. Declare only undefined value. Or type space name equals a value. Declare and assign initial value. Which one is used is determined by what you know at the time you're running the code. In the case of the card game, there's no way to know what card will end up at the top of the deck, so there's no way to assign an initial value. Just declare int deal card. Declare only. Now, in the case of the shooter game, it may always start level 1 with a pistol in the player's hand. If you know it's going to be a pistol, declare string weapon equals pistol. Declare and assign an initial value. Strongly typed languages only require you to declare a variable once, not every time it's used. A common mistake that beginners make happens when they declare and assign a value at the same time. So we're going to create a string player name equals Bob the Bad. Two things are happening on this line of code. We're declaring the variable player name, and we're assigning the variable Bob the Bad. So they do it this way the first time, so the second and third time you want to change the variable, you don't put the word string in front. If I try to change the player name and say string player name equals George the Good, this is bad because it declares player name twice. You only declare the variable once, and then you use it over and over and over. Again, if I say string player name equals Mary the Mean, bad. Declare the player name thrice, right? You don't have to redeclare the variable every time you use it. You declare it once at the top, and then you can use it many times. The second and third time, simply assign a new variable. Player name equals George the Good. This will replace Bob the Bad. Later on in the code, you say player name equals Mary the Mean. This will replace the George in the variable. You only have to declare the variable once at the top of the code. Once you've declared that variable once, you can just simply reuse it over and over again. So let's look at some examples of variables that are commonly used / needed when programming video games and discuss their type, their name, and the values we assign to it. Int level equals 1. What level is the player on? In many games, the level is a critical variable. Obviously, the game starts at level 1, and every time a player completes a level, they bump to the next level. Hard to think of it as anything but an integer, but I do want you to think about the range of values that are appropriate. Most games have a limit where 10, 15, or 20 is the last level of the game, and when you complete that level, you have finished the game. In this case, it's a good idea to comment on the range. Any value outside the range should be considered a serious bug. So int level equals 1. What level the player is on, the range should be 1 to 10. Next example, int x comma y. You can declare two variables at the same time if you comment separate. This would be a coordinate in 2D, position on the x and y axis. All right. For graphics in 2D space, integers should be sufficient. You may even be able to set a fixed range depending on the scrolling, no scrolling, and the screen resolutions the game supports. However, you will need to separate x and y coordinate for every element drawn on the screen. The math in 2D tends to be simpler. We are not too worried about rounding errors like with 3D graphics. In three-dimensional graphics, I might be tempted to declare them double x, comma, y, comma, z. Again, I'm declaring three variables on the same line by comma separating them. This would be your coordinate in three-dimensional space, your position on the x, y, and z axis. Now, I'm not saying you have to use floating point numbers for 3D graphics, but you're much more likely to want to use the double type in 3D space. With a 2D game, things stay the same size. With 3D, move forward a little and things are drawn slightly larger. Move backwards and they're drawn slightly smaller. This gives the illusion of movement. You do not want rounding errors to compound over and over again in 3D space. You're much more likely to use double or floating point numbers in 3D graphics than 2D graphics. Speaking of rounding errors, money is many times a component of a game. Let's declare a double balance equals 0.0. This is the player's current cash or bank balance. Any game that has players purchase items obviously needs to track how much money they currently have. You could make this an integer if you were to limit to whole dollars. But if you want to charge something like $9.99 of virtual money for an item, it could be a floating point value. Here you want to make sure you display or keep 2 significant digits after the decimal point. Never show a balance of $47.36.364564 on the screen. Don't even keep that in the variable. It should be 47.36 on the screen and in the variable. Always only keep 2 decimal points when talking about money. Also, not everything is always a number. A good online game should display some sort of name on your screen and to other players. So let's put a string nickname variable. This will be the name shown to other players. Never show their real name for privacy reasons. No doubt this is going to be a string type, especially for online games that kids play. A unique screen name or nickname is required to identify the players to others in the online arena. Speaking of online games, users also want to see some sort of ranking or strength of the other players. So maybe that's a char variable. We'll declare a char rank. We'll give A the highest rank, meaning you're a real good player, B for a medium rank, B for a good rank, C for an average player, E is and F means you're terrible. Using a grade letter to rank players has the advantage of being understandable. Everyone understands A is best, C is average, and F is bad. But frankly, this is a design decision. It could be a string, it could be a number, it could be anything. I needed an example of a variable to store single characters, and this is what I picked. Another example, Boolean paid user. True if the player is paid for the game, false if the player is not. Many games now offer free downloads that limit the player to 2 levels or prevent them from going to certain places in the game until the user purchases the game. It allows players to try before they buy and provides powerful incentive to pay up if they like the game. A Boolean variable can only hold 2 values, true or false. Only when this variable is true will it allow players to the restricted areas of the game. How would you declare a time variable? Many games display an elapsed time on the screen, maybe how long it has taken to complete the level you are on. So it starts at 0:00 and counts up. When you finish the level, if it reads 12:32, it means it took 12 minutes and 32 seconds to complete a level. What variable or variables would you declare to use to display a time variable? I'd go with seconds. Int times seconds equals 0. Track the elapsed time in seconds. 70 seconds means 1 minute and 10 seconds. I would not go with different variables for hours, minutes, and seconds, or even use a double type. If I track the total number of seconds, I can easily calculate minutes and hours. Now, I did not go through all these examples because I don't expect you to exactly declare. Correction. I did not go through all these examples because I don't expect you to exactly declare and use these variables as I have. It is clear there are many ways to declare and use variables that accomplish the same task in a different manner. What I do want you to do is pause the current game the next time you play, look at the frozen screen at the information that's displayed on the screen, and ask yourself, what variables and their types are storing the information I see on the screen? Now that we know how to declare and create variables, let's look at what we can do with them. All computer languages support the basic arithmetic operators. Addition is the plus sign, subtraction, the minus, multiply, and divide. The general format for an assignment statement is that variable equals some expression with a semicolon to end the line. If expression seems a little vague, that's because it is. An expression can be a literal value, like health equals 100, or balance equals 30.44. It could be another variable. Player age equals age input, or x position equals start x. It could be a result of an arithmetic expression. Time equals time plus 1. Addition. Health equals health minus 5. Subtraction. Strength equals strength times 2, multiplication. Balance equals balance divided by 2.0, division. The key is to match the type. If health is an integer, it should be assigned an integer. Looking at the examples above, balance is a double. It's assigned a literal with a decimal point and divided by 2. The semicolons at the end of the expression are very, very much required. Literals do not change. Variables do. Every time a literal example above executes health and balance get the same values. But in the next example, player age and X position get a different value every time the code executes. Just as a reminder, you can combine a declaration with an assignment. You could say int health equals 100, double balance equals 30.44, but you only need to declare the variable once. So don't put an int or double in front of health and balance every time you try and use those variables. Let's assign arithmetic expressions using precedence. The order is important. If I say x position equals 3 plus 2 times 4, will y position equal 11 or y position equal 20? All programming languages follow standard arithmetic precedence, where multiply is more important than addition. So 2 times 4 is done first, and the result 8 is added to 3 for the correct result of 11. Simple third grade math. Below is a table showing the highest precedence on top and the lowest precedence to the bottom. This is a partial list. So this table indicates that the parentheses has very high precedence. Now, multiplication and division have equal precedence when compared to each other, but it's lower than parentheses. Plus and minus are equal to each other, but lower than multiplication and divisions. All things being equal, expressions are evaluated left to right. The assignment or equal operator has a very, very low precedence, so it's done last. As we all should know, anything in parentheses has very, very high precedence. So if we really want the answer above to be 20, put the addition in parentheses and it'll be done first. X position equals parentheses 3 plus 2. End of parentheses times 4. So the 3 plus 2 gets done first, is a 5. Multiply that by 4 and the result is 20. Now, we can also declare variables that do not change. They are called constants. I'm going to say final int max health equals 100. This is Java syntax here. The Java keyword says do not allow this value to change ever. It's called a constant. And by convention, not by rule, they are uppercase to indicate we do not assign a new value to this. Once max health is set to 100, it stays 100 forever. Constants are much preferred over hard-coded literals used throughout the code. What if there were 20 places in the code where you add the player's health points to make sure it does not exceed 100? Well, if your boss decides at the last minutes players should be allowed 150 health points, with a hard-coded 100, you'd have to find and replace 100 different places where you used that 100. With a constant, you have to find and change that one place at the top of the code. I'll say final int max health equals 150. Change this one declaration and all 20 checks for max health adjust themselves. Another issue is mixed variable types and arithmetic. In general, computers want to do arithmetic on the same type of values. Int x position equals 3 plus 2 plus 4. Add int values, return an int, and assign it to an int variable. Double balance equals 100.0 minus 27.50 minus 13.25. When I subtract or do arithmetic on a double variable, I want all the operands to be double variables. However, it does happen that sometimes we do what's called mixed mode arithmetic. Let's do balance equals balance plus 2. Technically, this is kind of wrong. Balance is a double variable, but I'm adding to it an int variable without a decimal point. Computers do not like mixing types, so some automatic conversion or upgrade of the type occurs. When we type in balance equals balance plus 2, it's really converted to balance equals balance plus 2.0. The computer does not mind changing the int 2 to the double 2.0 because they are essentially the same value. You need to be careful though. This automatic upgrade from int to double only works in one direction. If I declare a double cash balance and an int amount equals 45, cash balance equals amount works okay. Cash balance can hold an amount. It'll basically upgrade to 45 to 45.0 and assign it to cash balance. If I say cash balance equals 33.22, that's okay. The 33.22 is a double value. I'm assigning it to a double variable. However, if I try to say amount equals cash balance, that's what we call a syntax error. Amount cannot hold the 0.22. You can't put a number like 33.22 in an int variable. It just doesn't fit. It's a one-way street. Integers will automatically be upgraded to doubles, but doubles are not downgraded to integers. It's easy. 45 and 45.0 are essentially the same value, but 33.22 and 33 are clearly not the same value. Now, there are ways to explicitly convert numbers. This is called a typecast. If I say amount equals parentheses int end of parentheses cash balance, there will be no error. The typecast will force the conversion to an int. It'll drop the 0.22. The typecast just chops off the decimal point. Both 33.22 and 33.99 would be converted to the integer value 33. So be careful. A typecast can lose information. Increment, decrement, and shorthand assignment operators. Many video games, especially arcade versions, award the player points for every task accomplished. If you and a friend played the same game, the person with the most points at the end is the winner. An arcade game like Pac-Man, for example, would award a point for every dot swallowed. Man, I'm old. I hope you kids know the game Pac-Man. Obviously, a variable needs to be allocated to hold the points earned and adjusted as play continues. Turns out there's more than one way to add 1 to this variable. If I say point total equals point total plus 1, sort of the standard way to it, I can do point total plus plus, or I can do point total plus equals 1. All three of these examples do the same thing. Add 1 to the variable point total and store the result in the variable point total. The first example would be obvious, should be obvious, but the second one is new. The plus plus is called the increment operator, and it adds 1 to the variable and stores the result back in that variable. It's a shortcut, a convenience. Adding 1 to a variable is a very common operation. If you make the programmer type in the full version, discourages using If you make the programmer type in the full version, discourages using longer descriptive variable names. The third example that uses plus equals 1 is called a shorthand assignment operator. This time, though, you don't have to just add 1. You can add any number you want to point total and store the result back in the point table. Let's say you get 25 bonus points if Pac-Man swallows a cherry. This could be done two ways. You could say point total plus equals 25, or you could say point total equals point total plus 25. Both commands do exactly the same thing. Add 25 to point total and store the result back into point total. Again, it's a shorthand, a convenience. If you force a programmer to type out the whole thing, they're more likely to use short variable names, and nobody wants to see stuff like this. PT equals PT plus 25. Who's going to remember that PT is the point total, right? I'd much rather see a point total plus equals 25 than a PT equals PT plus 25. Again, these things are just shorthands, right? They're a convenience. Now, if there's more than one way to add 1, there's certainly going to be more than one way to subtract 1. In the Pac-Man game, he loses health points every time he runs into a ghost or another object. When health reaches 0, he's dead. We need to subtract from health total. These three commands do the same thing. Health minus minus, health minus equals 1, or health equals health minus 1. The decrement, or minus minus operator, subtracts 1 from the variable and stores the result back into the same variable. If health contains the value 17, health minus minus changes it to 16. The decrement operator does the same thing that health equals health minus 1 does. The minus equal is another shorthand assignment operator. It's not limited to subtracting 1. If we lose 25 health points for running into a ghost, then these two commands would do the same thing. Health minus equals 25 would subtract 25 from health and store the result back into the health variable. Same thing as health equals health minus 25. We don't have to use the increment plus plus or decrement minus minus or the shorthand assignment operators plus equals, minus equals, multiply equals, divide equal operators. You could always use a full length command. But if these operators encourages you to use longer descriptive variable names instead of short abbreviated one, that's a good thing, and go ahead and use them. Variables come in different sizes. Obviously, not all variables are created equal. Different amounts of computer memory are allocated to hold different types of variables. The amount of memory allocated determines the minimum and maximum values you can store in a variable. In Java, variables have a set fixed size that cannot be changed. In other languages, this might not be true. Here are some Java sizes. An int is 4 bytes of computer memory. The largest value is a positive 2,147,000,000. The smallest value you can store in an integer variable is a negative 2,147,000,000 and change. The double variable type, is 8 bytes of computer memory. That gets you about 16 digits of precision. The Java integer type, there are only so many combinations of zeros and ones that fit into 4 bytes or 32 bits of computer memory. You cannot store an infinitely large number in a fixed size memory. Storing the value 10 billion in an integer variable simply will not fit. It is the programmer's responsibility to make sure you do not store extremely large or extremely small negative numbers into an integer variable. With floating point or double variable types, it's not so much the size of the number, but the digits of precision. The Java double type supports approximately 16 digits of precision. For example, if you wanted to create this constant, final double pi equals 3.1415962xxxxxx. Now, I don't know the value of pi to 16 digits, but if I did, I could fill in those x's with real numbers. But only to 16 digits. Any more digits will not fit into 8 bytes of computer memory. Remember, not everything is a number. Computers operate on characters too. And Java allocates space for character variables. If I declare a char in Java, 2 bytes of the Unicode character set, or universal code, is allocated. Java chose to use 2 bytes of memory for each character. There is an older 1-byte character set named ASCII, or ASCII, American Standards Committee for Information Interchange. It was designed in the 1950s, but with only 1 byte of computer memory. So there are at most 256 possible characters. In fact, only uses 128 of them. That's fine for the English language, but that's not so good when characters are needed from other languages. So Java supports what's called the 2-byte Unicode, or universal code, which allows over 16,000 characters and can handle languages like Chinese, Japanese, as well as English. By the way, Unicode is backwards compatible to ASCII. The first 256 values of Unicode exactly match the 256 values of ASCII. Strings. Now, I'd like to tell you how much memory it takes when you create and store a value in a string variable, but I can't. This is because Java stores strings as objects, and the size is entirely dependent on how many characters are in the string. I know it takes at least 2 bytes per character, plus the overhead for the object itself. Now, think of a string of pearls that forms a jewelry object. Think of a string of lights that forms a Christmas object. Think of a string of characters that form a Java string object. A string is a Java class used to build string objects. Right? The big difference between a normal variable type like int and double and an object, more overhead with the object. Java made a decision. An int or a double are small and simple enough they don't need the overhead of an object. But strings need an object. Why? Because no one knows how big to make a string. Will the string contain 2 characters, or 200 characters, or 2,000 characters? As an object, it will allocate exactly the number of characters needed to store the data. If you assign 10 characters to a Java string object, it will allocate space for 10. Assign 25 characters to a string object, it will allocate space for 25. By dynamically sizing string objects, it actually saves memory because you don't have to pre-allocate a bunch of unused space. The extra overhead needed to make a string an object is definitely worth it. The string crosses the line. It's too complicated. It needs to be an object. Now, please be aware, based on context, Java decides what a value is. Look at these examples. Int name equals 1. Char name equals single quote 1 and a single quote. String name equals double quote 1 and a double quote. With no quotes around it, a plain old 1 is considered to be an integer, and the name better be an integer variable. With single quotes, it's assumed to be a single character, and the name should be a char variable. If you put single quotes around something, Java treats that as a char variable. With double quotes, it's assumed to be a string, and the name should be declared a string variable. Right? When something appears inside double quotes, it's called a string literal, and Java automatically creates a string object out of that literal. So let's look at declaring some string variables. Let's say string name equals John, John. If you break this simple line of code down, string is the type, name is the object variable, and John is the string literal. Java takes this literal, builds a string object, and assigns it to the object variable name. Let's do string last name equals Doe, and string full name equals name plus double quote space end of double quote plus last name. For the plus line, strings do what's called concatenation. The plus operator concatenates the string based on the contents. It puts 2 strings or 3 strings together and makes them a larger string. When Java sees the plus between 2 numbers, it does numeric addition. Int total equals 3 plus 2. A plus sign between the 3 and the 2 indicates numeric addition. The answer is 5. String total equals double quote 3 and a double quote plus double quote 2 and a double quote. This is string concatenation, and the total is 32. When you put 2 smaller strings together, they make the larger string 32. What if you mix mode them? What if they're a mixed type? A string on the left side of the plus and an integer on the right side of 2. This becomes 32. Mixed types go to string. Why does mixing the types do string concatenation? Because you can convert any number of string, but you cannot convert any string to a number. Program errors, syntax, runtime errors, logic errors. Nobody types perfect code the first time. There's always errors or mistakes made when writing a computer program. There are 3 basic categories of errors that may occur. Number 1 is called a syntax error. This is fairly easy. It violates the rules of Java. This is usually something simple like missing a semicolon, a curly brace, or code. For example, string name equals double quote Bob, semicolon. This is a syntax error because I'm missing the closing double quote. When you commit a syntax error, the IDE and/or the compiler lights up your mistake in red and tells you right away you'd made a mistake. The second type of error is called a runtime error. The program compiles, the program runs, but crashes with some sort of fatal error. If I do balance equals balance divided by factor, if factor happens to contain some sort of 0, then a divide by 0 error would occur and the program would crash. The third type of error is called a logic error. where the program runs, but there are no crashes, but it just produces incorrect results. Logic errors are difficult to show because the program runs, it just doesn't produce correct results. Something gets output incorrectly. For example, your character has a current cash balance of $432. They purchase a weapon for $100. If the new cash balance is not $332, that is a logic error. You pay $100 for something, your cash total goes down by $100. It doesn't matter if it's more or less. If it doesn't do the calculation right, the program's not going to crash. It's still going to show you something on the screen. It's just incorrect. Another example, your player has obtained an access card to open a specific door. When they approach the door, it should open. Somehow the logic of your code is wrong and the door fails to open. That's a logic error. You have the card needed to go through the door should open. It just doesn't. That is called a logic error. The ability to find and correct errors is the one thing that separates bad programmers from good programmers. Everyone makes mistakes, but the number one attribute of a great coder is how fast they can find and fix them. Thanks, GameSci.com. GameSci.com.